The Big Bang Theory has a crack, and this discovery just widened it. For almost 100 years, humanity believed it had finally uncovered the story of creation itself. The Big Bang Theory became more than a scientific model. It became the foundation of modern cosmology, the invisible framework behind everything we thought we understood about space, time, galaxies, and existence. According to this story, the universe emerged from an unimaginably hot and dense beginning nearly 8 billion years ago. Stars formed, galaxies evolved, time moved forward. Everything appeared to fit together with astonishing precision. But something strange has begun to happen in the darkness beyond our reach. The deeper we look into the cosmos, the less the universe behaves the way it is supposed to. Astronomers expected to find primitive structures in the early universe, tiny galaxies, chaotic formations, young cosmic systems still struggling to assemble themselves after the birth of space and time. Instead, what they found were gigantic galaxies already mature, already organized, already glowing with the complexity scientists believed should have taken billions of years to develop. Imagine discovering a fully grown city buried beneath the foundations of ancient civilization, streets already built, towers already standing, lights already shining. That is the feeling spreading through modern cosmology right now. And the unsettling part is not simply that these objects exist, it is that they exist too early. Much too early. The timeline itself is beginning to fracture. Some of these galaxies appear so massive and evolved that, according to current models, they should not have had enough time to form after the Big Bang. Entire structures seem to emerge from the cosmic dawn far faster than physics predicted. Supermassive black holes already existed when the universe was still in its infancy. Ancient light arriving from the edge of observable reality is carrying information that no longer fits comfortably inside the equations scientists trusted for generations. This is not science fiction, this is happening now. Inside observatories, universities, and research institutions around the world, cosmologists are confronting a possibility few imagined they would ever face during their lifetimes. The universe may be more complicated than the story humanity built to explain it. And perhaps even more unsettling than that, the universe may not care about our expectations at all. There is a strange emotional moment that appears whenever human beings believe they finally understand reality. It happened when ancient civilizations believed Earth stood at the center of creation. It happened when we believed the Milky Way was the entire universe. And now, it may be happening again, as new discoveries begin to expose hidden cracks beneath one of the greatest scientific achievements in human history. Because the more powerful our instruments become, the more the cosmos reveals something terrifying. Not ignorance, but contradiction. Some scientists remain cautious. Others believe the tension will eventually disappear with better data. But there are also researchers quietly asking a far more dangerous question. What if these discoveries are not small errors inside the theory? What if they are warnings that the theory itself is incomplete? Tonight, we are going to travel to the edge of the observable universe, where ancient light has been crossing space for billions of years just to reach us now. We are going to explore impossible galaxies, cosmic anomalies, invisible forces, and discoveries so unsettling that they are forcing scientists to rethink the origin story of reality itself. Because somewhere beyond the first stars, hidden in the oldest corners of existence, the universe may be trying to tell us something we were never prepared to hear. Humanity's greatest story about creation. Before the universe began to challenge our understanding, the Big Bang Theory represented one of the greatest intellectual triumphs our species had ever achieved. For thousands of years, human beings looked into the night sky and searched for answers. Ancient civilizations imagined gods moving the stars across the heavens. Philosophers debated whether the universe had always existed or whether it emerged from some divine beginning hidden beyond human comprehension. Generation after generation stared upward into the darkness with the same unanswered question echoing across history. Where did all of this come from? Then, in the 20th century, humanity experienced something extraordinary. For the first time, science began constructing a coherent story about the birth of reality itself. It started with a discovery so profound that it changed cosmology forever. Astronomers realized the universe was expanding. Galaxies were not standing still in an eternal cosmic ocean. They were moving away from one another, as if space itself were stretching in every direction. The farther galaxies appeared, the faster they receded into the darkness. The implication was staggering. If the universe is expanding today, then in the distant past, everything must have been closer together. Closer, denser, hotter. This realization transformed the cosmos from something static into something alive with history. Suddenly, the universe had a past, a beginning, a moment when everything we know was compressed into an unimaginable state beyond ordinary understanding. The idea sounded almost absurd at first, an entire universe emerging from an incomprehensibly tiny origin. Matter, energy, space, time itself, all born from a primordial event so violent that it shaped every galaxy, every star, every planet, and every living creature that would ever exist. But then came the evidence. Again and again, the universe seemed to confirm the theory. Astronomers discovered the faint afterglow of the early cosmos, the cosmic microwave background radiation, ancient light still traveling across space billions of years after the birth of the universe. It was like finding fossilized echoes from creation itself. Tiny fluctuations inside this ancient radiation perfectly matched predictions made by the Big Bang model. The theory became stronger with every decade. Scientists could explain how the first elements formed. They could model the growth of galaxies. They could trace the evolution of stars across cosmic history. Modern cosmology began assembling itself into a breathtaking narrative stretching from the birth of the universe to the existence of humanity. And perhaps the most emotional part of this discovery was not scientific at all. It was philosophical. For the first time, human beings realized the universe was not eternal and unchanging. It had evolved. It had transformed. It had a story. Every atom inside your body was forged during a cosmic process billions of years in the making. Every heartbeat is connected to stars that lived and died long before Earth existed. Humanity was no longer separate from the universe. We were part of its unfolding history. This realization changed the way people saw existence itself. The night sky stopped being merely decoration above civilization. It became a timeline, a memory, a vast cosmic archive containing the story of everything. And for decades, the Big Bang theory stood at the center of that story almost unchallenged. It became the backbone of modern cosmology because it worked. Its predictions aligned with observations so consistently that many scientists believed humanity had finally reached a stable understanding of cosmic origins. The biggest mysteries seemed no longer impossible to solve. It appeared that science was slowly illuminating the darkness surrounding creation itself. But there is something dangerous about certainty, especially in science, because the universe has a habit of humbling every generation that believes it has reached the final answer. And hidden deep within the ancient cosmos, beyond the reach of earlier telescopes, there were objects waiting in silence. Objects so old, so massive, and so unexpected that they would force scientists to confront a terrifying possibility. The universe may have evolved far differently than we imagined, and the machine that uncovered this mystery was unlike anything humanity had ever built before. The telescope that accidentally found the impossible. Humanity has always built machines to see farther than the human eye allows. From the first primitive lenses pointed toward the moon to giant observatories standing beneath isolated deserts, every new telescope expanded the borders of reality itself. Each generation believed it was approaching the edge of the unknown. And each time, the universe revealed something larger, stranger, and more unsettling than expected. But nothing prepared modern astronomy for what happened when the James Webb Space Telescope opened its golden eye to the ancient cosmos. This telescope was not designed merely to observe distant galaxies. It was designed to travel backward through time, because in astronomy, distance and time are inseparable. The farther we look into space, the farther we look into the past. Light from distant galaxies takes billions of years to reach Earth, meaning every observation becomes a glimpse into ancient cosmic history. Webb was engineered specifically to capture the faint infrared glow of the earliest structures that emerged after the Big Bang. Scientists expected to witness the universe in its infancy, a chaotic cosmic dawn, tiny galaxies slowly assembling themselves from primordial gas, young stars beginning to ignite inside immature systems not yet fully formed, the first fragile chapters of cosmic evolution. Instead, Webb found something that stunned astronomers around the world. The early universe already looked old, almost impossibly old. Massive galaxies appeared where none should exist. Some were so bright, so structured, and so mature that they seemed to belong to a much later era of cosmic history. These systems contained enormous numbers of stars despite existing only a few 100 million years after the supposed birth of the universe. In cosmic terms, that is almost instantaneous. It was as if humanity had opened a history book, expecting to see the first sparks of civilization, only to discover fully developed empires already standing at the beginning of the timeline. And the deeper Webb looked, the stranger the discoveries became. Ancient galaxies appeared far larger than predicted. Some researchers found evidence suggesting unexpectedly rapid star formation occurring across the early universe. Even supermassive black holes, objects so extreme that not even light can escape them, appeared far sooner than existing models could comfortably explain. The problem was not simply that these objects existed, the problem was time. There should not have been enough of it. According to standard cosmology, the infant universe was still emerging from its earliest stages. Matter should have required far longer to organize into structures this complex. Gravity alone should not have been able to assemble galaxies of such size and maturity so quickly after the Big Bang. For many scientists, the first reaction was caution. Perhaps the measurements were wrong. Perhaps the galaxies only appeared larger. Perhaps future data would resolve the tension. That is how science works. Extraordinary claims require extraordinary evidence. But as more observations arrived, the discomfort inside cosmology began to grow. Because Webb was not producing one isolated anomaly. It was uncovering pattern after pattern that seemed increasingly difficult to reconcile with the expected timeline of the universe. And suddenly, a quiet question began spreading through scientific discussions. What if the early universe evolved much faster than we thought? That question may sound technical at first, but hidden inside it is a profound threat to modern cosmology. If galaxies formed earlier than expected, then either our understanding of cosmic evolution is incomplete, or the conditions of the primordial universe were radically different from current theories suggest. Either possibility changes everything. And there is something deeply humbling about this moment in human history. For decades, we believed better technology would simply confirm what we already understood. Instead, our most advanced telescope may have exposed the limits of our knowledge. The machine built to strengthen the standard model of cosmology may now be revealing its hidden weaknesses. This is the paradox of scientific progress. Every powerful instrument humanity creates does not merely expand our vision, it also expands our ignorance. Because each time we illuminate a darker corner of the universe, we discover mysteries waiting beyond it. And now, cosmologists are confronting an increasingly uncomfortable realization. The universe may have assembled itself far too quickly for our theories to explain. The cosmic timeline that no longer fits. There is a silent assumption hidden inside modern cosmology, an assumption so fundamental that almost every model of the universe depends on it. The universe needed time for matter to cool, time for gravity to pull particles together, time for stars to ignite, time for galaxies to grow from tiny irregularities into the colossal structures scattered across the cosmos today. According to the standard model, cosmic evolution was a gradual process unfolding across billions of years, like an immense universal clock. But now, that clock may no longer be keeping the right time. The discoveries emerging from the distant universe are forcing scientists to confront a deeply uncomfortable possibility. The early cosmos may have evolved far faster than current physics allows. And if that is true, something inside the timeline is broken. Imagine planting a seed in the ground and returning the next morning to find a fully grown forest already standing there, trees towering into the sky, roots buried deep beneath the earth, entire ecosystems already thriving. That is essentially what astronomers are seeing in the ancient universe. Galaxies that should have been young and primitive already appear mature. Some contain enormous populations of stars despite existing astonishingly close to the supposed beginning of cosmic history. Others seem to possess organized structures that should have required far longer to emerge. The contradiction becomes even more unsettling when black holes enter the picture. Supermassive black holes are among the most extreme objects in existence. Millions or even billions of times heavier than the Sun, these gravitational giants usually require immense periods of time to grow. They form through processes involving collapsing stars, mergers, and relentless accumulation of matter across cosmic ages. Yet Webb and other observations suggest that some of these monsters already existed when the universe was still remarkably young. This creates a terrifying mathematical problem. There simply may not have been enough time after the Big Bang for these objects to form naturally under current models, and the universe does not appear interested in simplifying the situation for us, because every attempt to solve one contradiction seems to create another. Some researchers propose that early star formation was far more efficient than expected. Others suggest hidden physical processes may have accelerated galaxy growth during the infancy of the cosmos. There are theories involving exotic forms of matter, unusual gravitational behavior, or unknown conditions present shortly after the birth of the universe. But beneath all these possibilities lies a deeper fear. What if the timeline itself is incomplete? What if humanity's understanding of the early universe is missing a crucial chapter? This is where cosmology begins transforming from certainty into mystery once again. For decades, scientists believed they had reconstructed the broad history of cosmic evolution with remarkable precision. The sequence appeared elegant. First came the Big Bang, then particles, then atoms, then stars, then galaxies. Step by step, the universe evolved into the cosmos we see today. Now that sequence is beginning to blur, because the universe is presenting evidence that seems to arrive out of order. Objects appearing before they should, structures evolving too rapidly, complexity emerging almost immediately after cosmic birth. And there is something profoundly unsettling about watching reality resist our expectations. Human beings are deeply attached to narratives that make sense. We want beginnings to lead naturally toward endings. We want the cosmos to unfold according to understandable laws. But the deeper science explores the ancient universe, the more reality begins to resemble something stranger than a perfectly ordered story. It begins to resemble a puzzle with missing pieces. Some cosmologists remain optimistic that future discoveries will eventually repair the tension. Science has survived crises before. New data often forces adjustments without destroying the larger framework. But others are beginning to suspect that these anomalies are not temporary inconveniences. They may be warnings that the universe is more alien than we imagined. And hidden inside the oldest light ever observed, there may already be signs that the cracks in cosmology began far earlier than anyone realized. The ancient light carrying a hidden contradiction. Long before galaxies formed, before planets existed, before the first stars illuminated the darkness, the universe was filled with fire, not ordinary fire, a cosmic ocean of energy so hot and dense that matter itself could barely exist. In those first moments after the Big Bang, the universe was a blinding storm of particles and radiation locked together inside an expanding inferno. Light could not travel freely. Space was opaque, flooded with chaos beyond human imagination. Then something extraordinary happened. The universe cooled, enough for atoms to form, enough for light to finally escape, and that ancient light is still traveling through the cosmos today. Scientists call it the cosmic microwave background radiation, a faint afterglow from the earliest observable era of existence. It is often described as the oldest light in the universe, a fossil from cosmic infancy itself. When astronomers first detected it in the 20th century, it became one of the strongest confirmations of the Big Bang theory ever discovered. It was considered a triumph, a whisper from the beginning of time. But hidden inside that ancient light, there may also be something else. A contradiction. Because the more precisely scientists study this primordial radiation, the more strange irregularities begin to emerge from the data. Tiny fluctuations in temperature spread across the universe. Unexpected asymmetries. Unusual patterns that refuse to disappear completely even after years of analysis. At first glance, these anomalies may seem insignificant. But in cosmology, tiny irregularities can carry enormous consequences. The cosmic microwave background is not just another astronomical observation. It is the foundation beneath modern cosmology itself. Scientists use it to estimate the age of the universe, calculate the distribution of matter, and reconstruct the conditions present shortly after the Big Bang. It is one of the most important pieces of evidence humanity possesses about cosmic origins, which means if there are unexplained inconsistencies hidden inside this ancient radiation, they may point toward something far deeper than simple measurement errors. One of the most unsettling tensions involves the expansion rate of the universe. Different methods of measurement are producing conflicting answers. When scientists calculate the expansion rate using observations of the early universe, including the cosmic microwave background, they obtain one result. But when they measure the modern universe directly using stars and galaxies, they obtain a different value entirely. The numbers do not align. This disagreement has become so persistent that it now has a name whispered throughout cosmology: the Hubble tension. And despite years of effort, no one has fully resolved it. It is as though the universe is telling two different stories about its own expansion history. One from the ancient cosmos, one from the modern cosmos. Both cannot be completely correct at the same time. This is where the emotional weight of the mystery begins to deepen, because the cosmic microwave background was once viewed as a symbol of certainty, a relic proving humanity had successfully decoded the early universe. Yet now, the very evidence that strengthened the Big Bang theory may also contain subtle clues that the standard model is incomplete. And perhaps the most fascinating part of this entire mystery is the realization that these contradictions were always there, hidden, embedded in ancient light, crossing billions of years of space, waiting for civilization to become technologically advanced enough to notice them. There is something haunting about that thought. At this very moment, photons born near the beginning of time are still arriving on Earth, carrying messages from an era no human being can truly imagine. Tiny variations inside that ancient radiation may hold information capable of reshaping humanity's understanding of existence itself. And the deeper scientists investigate these signals, the more another unsettling realization begins to emerge. Most of the universe may be made of forces we cannot even see, the invisible universe nobody can explain. There is a deeply disturbing truth hiding beneath modern cosmology. Everything humanity has ever seen, touched, measured, or experienced may represent only a tiny fraction of reality. Every star in the night sky, every planet, every galaxy, every human being who has ever lived, all of it together accounts for only a small percentage of the universe. The rest is invisible, and nobody truly knows what it is. For decades, scientists believed the cosmos was mostly made of ordinary matter, the same material forming stars, planets, oceans, and human bodies. But as telescopes became more powerful and observations more precise, astronomers encountered something impossible. Galaxies were behaving as though they contained far more mass than anyone could see. Stars near the outer edges of galaxies were orbiting far too quickly. According to gravity, these galaxies should have torn themselves apart long ago. There simply was not enough visible matter holding them together. Yet, they remained stable. Something hidden was exerting gravitational influence across the universe, something invisible. Scientists gave this mysterious substance a name: dark matter. But naming a mystery is not the same as understanding it. To this day, nobody has directly observed dark matter. No laboratory has definitively identified the particles responsible for it. Humanity cannot see it, touch it, or fully explain it. And yet modern cosmology depends on its existence. Without dark matter, galaxies should not form the way they do. Large-scale cosmic structures become nearly impossible to explain. It is one of the strangest situations in science. An invisible substance believed to make up a massive portion of the universe, despite remaining completely undetected. And somehow, the mystery becomes even more unsettling, because dark matter is only part of the problem. In the late 20th century, astronomers discovered that the expansion of the universe is accelerating. Galaxies are not merely drifting apart through cosmic expansion. They are moving away from each other faster and faster over time. Something is pushing the universe outward, something powerful enough to overcome gravity itself across unimaginable distances. Scientists called this force dark energy. Again, the name sounds scientific and precise. But beneath the terminology lies an uncomfortable reality. Nobody fully understands what dark energy actually is. Together, dark matter and dark energy are believed to compose most of the cosmos. Ordinary matter, the visible universe humanity once believed represented reality, may account for only a tiny cosmic residue left floating inside forces we barely comprehend. Think about the psychological weight of that realization. Modern cosmology, despite all its sophistication, may be describing a universe largely built from unknown components. Entire theories about cosmic evolution depend upon invisible entities science cannot directly explain. And yet, these invisible forces appear absolutely necessary for the universe to behave the way it does. This creates an extraordinary tension inside modern physics, because some scientists are beginning to ask a dangerous question. What if dark matter and dark energy are not missing ingredients? What if they are signs that the equations themselves are incomplete? Imagine trying to understand the movement of oceans while remaining unaware of gravity. You might invent invisible mechanisms to explain the tides without realizing the deeper laws governing reality were misunderstood from the beginning. Some researchers fear cosmology may be facing a similar situation now. Perhaps the universe is not filled with invisible substances at all. Perhaps humanity's understanding of gravity, space, or cosmic evolution is fundamentally flawed. And if that possibility turns out to be true, the implications are staggering, because it would mean that modern cosmology may have constructed its model of reality around placeholders hiding a deeper ignorance. The terrifying beauty of science is that it never guarantees comfort. Every discovery capable of expanding human knowledge also carries the potential to destabilize what we once believed was secure. And the deeper cosmologists investigate the invisible universe, the more anomalies begin appearing across the cosmos like fractures spreading beneath the surface of reality itself. Strange alignments, impossible structures, contradictory measurements, signals that refuse to fit inside the existing framework. The universe is not becoming simpler. It is becoming stranger. The growing list of cosmic anomalies. At first, scientists believed the contradictions were isolated. One unusual galaxy, one strange measurement, one unexpected observation that future research would eventually explain away. That is how science normally works. The universe is complicated, instruments have limits, and anomalies often disappear once better data arrives. But something unsettling has begun happening inside modern cosmology. The anomalies are multiplying, and they are appearing in places too distant, too massive, and too consistent to comfortably ignore. It is as though the universe is quietly resisting the story humanity constructed to explain it. One of the strangest mysteries involves the large-scale structure of the cosmos itself. According to standard cosmology, matter should be distributed across the universe in a mostly random and uniform way when observed on enormous scales. Yet, astronomers continue discovering gigantic structures stretching across distances so vast they challenge expectations about how the universe evolved. Immense galactic walls, clusters connected across unimaginable distances, patterns that seem almost too organized. Some structures appear so enormous that, according to current models, the universe may not have had enough time since the Big Bang to assemble them naturally. And then there are the strange alignments. Certain galaxies appear to rotate in unexpectedly coordinated directions. Regions of the cosmos exhibit unusual asymmetries that should not exist if the universe evolved uniformly after the Big Bang. Even the cosmic microwave background, the ancient radiation once celebrated as evidence of cosmological order, contains peculiar features. Scientists still struggle to explain completely. Among them is something researchers sometimes call the axis of evil, a bizarre large-scale alignment detected in the cosmic background radiation itself. The name sounds dramatic, almost fictional, yet behind it lies genuine scientific discomfort. Because if these alignments are real and not statistical accidents, they may suggest the universe possesses hidden structures or behaviors modern cosmology cannot fully account for. And the tension does not stop there. Measurements of cosmic expansion continue producing contradictory results. The Hubble tension refuses to disappear. Different techniques still generate conflicting expansion rates for the universe, as though space itself is evolving according to rules scientists have not yet discovered. Even gravity, one of the oldest and most trusted forces in physics, begins behaving strangely at cosmic scales. Some galaxies rotate in ways that challenge expectations. Certain observations hint that the laws governing the large-scale universe may not operate exactly as current theories predict. Researchers investigating modified gravity models are beginning to explore the possibility that Einstein's understanding of gravity, despite its extraordinary success, may not fully describe the deepest behavior of the cosmos. And perhaps the most unsettling part of all this is not any single anomaly. It is the pattern emerging from them together. Because individually, each mystery can appear manageable, but collectively, they create a growing sense that cosmology may be entering a period of profound instability. There is a psychological moment that occurs before every scientific revolution. At first, contradictions are dismissed as noise. Then they become interesting, then unavoidable, and eventually they begin forcing humanity to reconsider assumptions once treated as unquestionable truths. This happened when Earth lost its place at the center of the universe. It happened when Newtonian physics gave way to relativity and quantum mechanics. And now, some scientists fear cosmology may be approaching another turning point, not because the Big Bang Theory is necessarily wrong, but because the universe may be more complicated than the theory alone can explain. There is something almost poetic about this crisis. Human beings built instruments capable of observing galaxies billions of light years away. We decoded ancient radiation from the dawn of time. We mapped the large-scale structure of the cosmos itself. And after all these achievements, we may have arrived at a humbling realization. Reality still contains layers hidden beyond our understanding. The deeper we look into space, the more the universe seems to transform from a solved equation into a living mystery once again. And now, a question once considered almost unthinkable is slowly entering serious scientific discussion. What if the Big Bang was not the true beginning after all? What if the beginning was never the beginning? For most of human history, the greatest mysteries existed beyond the reach of science. What happened before the universe began? Why does anything exist at all? Did time itself have a starting point? The Big Bang Theory appeared to bring humanity closer than ever to answering those questions. It described a universe emerging from an incredibly hot and dense primordial state nearly 13.8 billion years ago. For decades, many people interpreted this moment as the absolute beginning of everything. The birth of space, the birth of time, the birth of reality itself. But there is a strange problem hidden inside that idea. Science can describe what happened after the Big Bang with remarkable precision. What it still struggles to explain is what caused it. And the deeper physicists investigate the earliest moments of existence, the more uncertain the idea of a true beginning becomes. Because at the frontier of cosmology, some scientists are beginning to explore possibilities that sound almost impossible to comprehend. Possibilities suggesting the Big Bang may not have been the start of reality at all, only a transition. One of the most fascinating ideas is known as the cyclic universe model. According to this possibility, the cosmos may not experience a single beginning followed by endless expansion. Instead, the universe could move through eternal cycles of birth, evolution, collapse, and rebirth. One universe dies, another emerges from its remains. Cosmic history repeating across unimaginable spans of time. In this vision of reality, the Big Bang was not creation from nothing. It was the aftermath of a previous cosmic era. Another theory imagines something equally extraordinary, a cosmic bounce. Instead of beginning from an infinite singularity, the universe may have once existed in a previous contracting state. Space itself collapsing inward over billions of years until unimaginable density triggered a rebound, launching a new expansion phase that became the universe we inhabit today. If this idea is true, then the Big Bang was not the first moment of existence. It was a cosmic restart, and there are even more radical possibilities. Some physicists propose that our observable universe may represent only a tiny bubble inside a far larger multiverse. In eternal inflation models, space continuously generates new universes across an infinite cosmic landscape, each potentially governed by different physical laws, entire realities forming endlessly beyond the boundaries of observable existence. It is difficult for the human mind to process the scale of such ideas, not because they are fantasy, but because they emerge from serious attempts to solve genuine problems inside cosmology and theoretical physics. And perhaps the most emotionally unsettling realization is this. The closer science approaches the origin of the universe, the more the concept of before begins to lose ordinary meaning, because time itself may not behave the way human intuition expects. Near the beginning of cosmic history, the laws of physics enter conditions so extreme that our current understanding starts to break apart. General relativity and quantum mechanics, the two great pillars of modern physics, stop fitting together cleanly. Space fluctuates, time becomes unstable. Reality itself enters a domain where familiar concepts may no longer apply. This is where cosmology transforms into something almost philosophical. Human beings naturally seek beginnings because beginnings create emotional comfort. A starting point gives existence structure. It allows us to imagine a clear narrative for reality. But the universe may not obey narratives designed for the human mind. There may be no simple beginning, no clean starting line, only deeper layers of cosmic history stretching beyond our ability to observe. And that possibility changes the emotional meaning of existence itself. Because if the universe existed before the Big Bang, then reality may be far older, far stranger, and far more eternal than humanity ever imagined. The frightening beauty of science is that every answer creates new questions. And now, cosmologists are confronting one of the most disturbing possibilities ever seriously considered. Not merely that the universe had a different beginning, but that time itself may have behaved in ways completely alien to human understanding. The terrifying possibility that time worked differently. Human beings experience time as something constant. Seconds pass, hours disappear, stars rise and fall across the night sky, while life moves relentlessly forward. Every memory we possess is built upon the sensation that time flows in one direction, stable and irreversible. It feels so natural that most people never question it. But near the beginning of the universe, time itself may have behaved in ways so strange that human intuition completely breaks down. And if that possibility is true, then many of the contradictions haunting modern cosmology may not simply involve galaxies or black holes. They may involve reality itself. One of the deepest assumptions inside the Big Bang model is that the laws of physics operating today also govern the early universe. Scientists use those laws to reconstruct cosmic history step by step, tracing the evolution of matter from the primordial fireball to the formation of stars and galaxies. But the farther cosmologists push toward the beginning, the more unstable those assumptions become. Because there is a boundary where our equations stop functioning properly, a place where gravity, quantum mechanics, energy, and space collide under conditions so extreme that modern physics can no longer describe reality with certainty. This is the realm approaching the singularity, the point where density becomes infinite according to classical calculations, a place where time itself may lose its ordinary meaning. And this is where the mystery becomes truly unsettling. Some physicists believe time in the primordial universe may not have flowed the way it does now. The earliest cosmos may have existed in conditions where distinctions between past, present, and future blurred together. Cause and effect may have behaved differently. Space and time themselves may have emerged gradually from deeper quantum processes beyond ordinary human perception. Imagine trying to explain oceans to a creature that has only known deserts. That may be the limitation facing the human mind when attempting to understand the earliest moments of existence. Because every experience we have is shaped by the stable flow of time inside the modern universe. We evolved within a calm cosmic environment billions of years after the violent birth of reality. Our brains were never designed to intuitively comprehend what existence looked like near the beginning. And yet, the mathematics hints at something extraordinary. In some quantum gravity models, time may not have existed in a recognizable form before the Big Bang. Other theories suggest that time could emerge from relationships between quantum states rather than existing as a fundamental cosmic background. Some proposals even imply that what humans perceive as the forward movement of time may arise from increasing entropy rather than representing a universal truth. The implications are staggering. Because if time behaved differently in the early cosmos, then the contradictions surrounding galaxy formation, cosmic evolution, and the structure of the universe may not simply require new objects or forces. They may require a radically different understanding of reality itself. There is something deeply humbling about this realization. Humanity often imagines science as a steady march toward certainty. But the closer we approach the origin of existence, the more reality begins dissolving into abstraction, paradox, and mystery. Concepts that feel permanent inside everyday life become unstable at cosmic extremes. Space bends, time stretches, particles appear from emptiness. Entire universes may emerge from quantum fluctuations beyond ordinary comprehension. And standing at the center of all this is a fragile species living on a small planet, trying to reconstruct the history of existence from faint traces of ancient light crossing the darkness. Perhaps that is what makes cosmology so emotionally powerful. Not merely the scale of the universe, but the realization that reality is stranger than human imagination naturally allows. Because somewhere near the beginning of time, the universe may have operated according to principles so alien that our current understanding captures only a shadow of the truth. And that possibility leads toward one final question. What if the universe is still hiding its real origin from us? The universe may be hiding its real origin. There is a profound irony at the heart of human civilization. The more knowledge we acquire about the universe, the more mysterious existence becomes. For centuries, humanity believed the cosmos was simple. Ancient people imagined a small universe centered around Earth, surrounded by fixed stars and governed by eternal certainty. Then science expanded the horizon. Earth became one planet among many. The Sun became one star among billions. The Milky Way became one galaxy drifting through an ocean of unimaginable scale. And still, humanity kept searching. We built telescopes powerful enough to observe the edge of the observable universe. We detected ancient radiation left behind from cosmic infancy. We mapped galaxies across billions of light years. We developed mathematical models capable of reconstructing the evolution of reality itself. And after all of that, we may now be standing at the edge of another revelation. Not that we finally solved the mystery of existence, but that the mystery is far deeper than we ever imagined. Because hidden inside the growing cracks of cosmology lies a possibility both terrifying and beautiful. The universe may still be concealing its true origin from us. The contradictions continue to accumulate, galaxies appearing too early, expansion rates refusing to agree, invisible forces dominating the cosmos, ancient light carrying unexplained irregularities, structures too vast for current models to comfortably explain. Individually, each mystery may eventually find resolution. Science has survived crises before. Entire revolutions in physics emerged from contradictions once considered impossible to solve. But collectively, these anomalies are creating a strange feeling spreading quietly through modern cosmology. A feeling that humanity may not yet possess the complete story. And perhaps that realization should not frighten us. Perhaps it should inspire us. Because the history of science is not the history of certainty. It is the history of humility. Every generation believes it stands near the summit of understanding, until the universe reveals another horizon waiting beyond it. What once seemed complete becomes partial. What once seemed impossible becomes undeniable. Reality continuously expands beyond the borders of human expectation. That is the true power of discovery, not comfort, transformation. Somewhere tonight, beyond the reach of human eyes, ancient photons continue crossing the darkness after traveling for billions of years. Somewhere inside the cosmic abyss, galaxies are forming under conditions we still cannot fully explain. Somewhere beyond the observable edge of the universe, reality may extend into structures, dimensions, or histories humanity has not yet learned how to imagine. And still we search. That may be the most extraordinary part of all this. A species born on a fragile world orbiting an ordinary star became conscious enough to question the origin of existence itself. Against overwhelming cosmic scale, humanity learned to read the language of the universe through mathematics, observation, and imagination. We transformed curiosity into instruments capable of looking backward through time. And now those instruments are showing us something unexpected. Not the end of mystery, but the return of it. Perhaps the Big Bang Theory is incomplete. Perhaps future discoveries will reshape cosmology entirely. Or perhaps the current contradictions will eventually lead toward a deeper version of the same story humanity already tells itself about the universe. But regardless of the outcome, one truth remains undeniable. The cosmos is still speaking, still revealing fragments of a story larger than any civilization has ever fully understood. And maybe the greatest discovery waiting ahead is not a final answer about how the universe began. Maybe it is the realization that existence itself is far more mysterious, far more ancient, and far more beautiful than the human mind was ever meant to comprehend.